Okay, we are going to start chapter 11 as well. We're in the second lesson, and we're going to continue with our understanding of squares and rectangles and see if we can add a little bit more, really quick warm-up. I want you to identify the squares and the rectangles. So pause it. Can you write down any that are squares, any that are rectangles? So let's see. If I had to pick, I'm just going to go over and write them. A is a rectangle because opposite sides. 1, 2, 3, 4, 5, 6. B is a hexagon. No. C is a rectangle because it looks like opposite sides are equal. D is a square because it looks like all the sides are the same. E is a rectangle. Opposite sides are equal. H is not because it has like rounded curves, so it doesn't have any right angles. K is a rectangle because it has opposite sides are equal and it has 4. Let me just put this in there. Yes. Right angles, rectangle. J is neither. J would be a rhombus. I know it looks like a square and all the sides are the same, but if I hold up a sticky note in the corner, it looks like the angles are not 90 degrees, so that would be a rhombus. I is a square. F is a right triangle. And G is a trapezoid, it looks like. And so the only rectangles, we have 1, 2, 3, 4 rectangles and 2 squares. All right, let's try another one. Let's see. You right now need to pause and fill out and finish this page, and let's see what we remember from the last lesson about squares and rectangles, and then press play when you're ready. So first of all, I know 5 is a square because I see the tick marks that show that all the sides are the same. So if AB is 5 centimeters, then AD is 5 centimeters. And then that means BC is 5 centimeters and DC is 5 centimeters. If I wanted to find the perimeter of these, I would add up all the sides, 5, 10, 15, 20, and the perimeter would be 20 centimeters. I also have another square for number 3 because, again, I can see these tick marks to indicate all the sides are the same. So if FG is 7, then EF is 7, and EH is 7, and HG is 7. If I want to find the perimeter, I can add up all 4 sides, and I know that if I have 7 4 times, I would get to 28 inches. Then 4 is a rectangle, and I know that because I see this side's 4 and this side's 12, so they are not the same. So I could write 4 meters, 12 meters, and then this one says IJ, which is this one, which is 4, and this one says JK, which is this one, which is 12. Again, if I want to do the perimeter, I'm going to add the sides together. 12 plus 12 is 24. 4 plus 4 is 8, and then I get 32 meters. Last one, oh, this one kind of looks like a square, but I can see from the measurements that it's a rectangle because that's 15 and that's 13, so they're not the same. So these sides are the same and those sides are the same. So NO is opposite of 13, so that's 13, and PO is opposite 15, so that one's 15. All right, let's try. Where we're going to start breaking up these shapes. So this one's hard to do if you don't have it in front of you. So I'm going to model for you. So we basically have a rectangle and a square in this composite figure right here. And I can see that if I break it up, I have a rectangle and then I have a square. So we are trying to break these up. If I wanted to break it up in a different way, I could make a rectangle, another rectangle, and a bigger rectangle. If I wanted to see it that way, it doesn't really matter in this case. These I'm going to find ways to break it up. So I want you to visually just think about where you would draw the lines and then see if you agree. So I could do one there. I could do one there. Maybe some of you guys saw it differently and you just wanted to make one line right there. This one I could break up, have a shape here and a shape here. Maybe you saw it differently and you wanted to break it up into 3 smaller shapes. We're just taking these figures and breaking them up into squares and rectangles. And same thing here. I could break this one up, make that, and do that. And then I have one rectangle, another rectangle, and a square. Or I could break it up this way. Is this what I did? Now I forget what I did. I could do a square, a rectangle, and a rectangle. This one over here, I could just draw one line, which makes it really easy. And I have a longer rectangle and then a square right there. Let's see if there's any more. If for this figure, I would draw a line here, so I have a bigger square and a smaller rectangle. Here, this one's a little tricky. If you're looking at it and you kind of think, like, you can't do this because then these aren't squares or rectangles, so you would have to make this one cut through that way. And then you can see I have a shape right here, and I have another shape right there. All right, right now, I'm going to skip ahead this part. Actually, I'm going to keep this. Let's try function tables. This has nothing to do with what we were doing, but it's just a little review of some other things or some questions that you might see and kind of you're thinking about patterns in a table format. So it's using a function is a process that takes a number as an input and then another as an output. So it's like you put something in and then you get something out. So the in comes first. I have a 1 and what comes out is a 3. I started with a 2, what came out was a 4. I started with a 3, what came out was a 5. But the tricky thing is you have to look for the pattern, like what is the function or the rule that gets the input to the output. So if I go from a 1 to a 3, I'm really thinking am I adding, subtracting, multiplying, or dividing? I know I'm getting bigger, so I'm either adding or multiplying. I'm going to think that it's 1 plus 2 is 3. And then I'm trying to find a pattern. Oh, look, 2 plus 2 gets me 4. 3 plus 2 gets me 5, 4 plus 2 gets me 6, and then I can think, well, 5 plus 2, and I now know my output is 7. So it's trying to come up with some sort of rule or function for that table. So here is another one that also has a pattern where, again, we're trying to find the rule, but sometimes it's a pattern within the rule. So again, I put in a 1 and I got out a 6. I put in a 2 and I got out a 12. I could think, all right, well, 1 plus 5 is 6, but look at 2 plus 5 is not 12. 2 plus 10 is 12. You're kind of like, well, that's not working. You're going to try something else. I know that 1 times 6 is 6. Oh, I see 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6. And now I can see the pattern and the rule of this table right here. Here's one that I want you guys to stop, pause, and try to see. The only thing I want you to see is that there are some letters here which we call variables. That's okay. Look at, they tell me that the input is A and the output is B. So these all start with B equals, meaning if I'm going to do this, what I could do is I see B is right here, so I could check this. 26 equals, here's my A, 8 plus 21. Well, let's think. Is 8 plus 21 26? No, that doesn't make sense. I'm going to try B. So B is my output. I'm going to pick my first one. I'm going to do 26 is my B. My input is my A. 8 plus 3, no, 8 plus 3 is not 26, so it's not that one. My B is my output, so I'm going to put a 26 right here, equals A plus 18. 26 is 26 plus, oh no, I lied, is 8 plus 18, 26. Well, let's check it. 6, oh, it is, so that's a maybe. I'm going to come back to that one. And this one says B equals A plus 26. So let's see, is 26 equal 8 plus, no, that one doesn't work. Before I pick it, I'm just going to double check. It's saying my rule is whatever A is, I have to add 18, and then I will get my B. So let's try like this one. Is 14 plus 18 32? It is. So that one continuously works. So my answer there is C. Let's try another one. This one says, which list of numbers completes the table? I want you to pause it and then try this one. All right, so my input here is my X and my output is my Y. So I put in 2 and I got out 8. I put in 4 and I got out 16. I put in 6 and I put out 24. I'm looking for patterns. So first I'm thinking I'm getting bigger, smaller, I'm getting bigger. So I'm either adding or I'm multiplying. I'm noticing that a lot of the numbers are multiples of 2 or 4. I do know that 2 times 4 is 8. And let's see, 4 times 4 is 16. 6 times 4 is 24. What's 7 times 4? Well, I know that's 28. So I automatically see maybe one I think is the correct answer, but let's double check. Is 8 times 4 is 32. So I see that my correct answer for this one is A. All right, one more. Let's try this one. This one asks for the rule for the input-output. So this is my input. This kind of means what is my rule to get my output. So pause it, figure this out. All right, so let's see. What's interesting here is I'm noticing my input is bigger than my output, so I'm getting smaller. So I'm either subtracting or dividing. If I have 48 and I want to get to 42, if I take away, well, I'm going to try my rules right here. Is 48 plus 6 42? No, that makes no sense. 48 times 7 is 42. That makes no sense. This one says 48 minus 6. Well, if I do 48 minus 6, I do get 42. I'm going to try it here. Is 29 minus 6, 23. And I'm going to ask, is 24 minus 6, 18? The only other one I have to check is that D, which is divided by 5. 48 divided by 5 is not 42. That doesn't make any sense. So I know the answer here is C. Try to use A, B, C to help you, and it'll help you figure out what your possible things are and do no or maybe to break it down. All right, we're going to do 2 more. This one says, Catherine looks for birds every day on her way to the library. The table below shows the number of birds she has spotted this week. So here's her days, day 1, 2, 3, 4, 5, and how many birds she's spotted. What is the rule of the table? So again, you have 2 options here. You can just try to figure out the rule, like if I go 1 to 11, 2 to 20, I can try to figure it out. Or I already have 4 possible things, I can narrow it down. So this, like A says add 18 to the number of days to find birds. Well, is 1 plus 18, 11, and is 2 plus 18, 20, that one works, is 3 plus 18, 8, 9, no. So it's worked for like 1, but it's not really working for the others. B says multiply the number of days by 7 and add 4 to find the number of birds. What? All right, let's try this. Multiply the number of days by 7. So 1 times 7 is 7, and then is 7 plus 4, 11? That one works. Let's see, is 2 times 7 is 14, and then is 14 plus 4, 20, 14, 15, 16, no, that's 18, that doesn't work. I'm gonna try one more. 3 times 7 is 21, and 21 plus 4, no, this doesn't work. C, multiply the number of days by 9, and then add 2. 1 times 9 is 9, plus 2 is 11. 2 times 9 is 18, plus 2 is 20. 3 times 9 is 27, plus 2 is 29. This one's working so far. I'm going to put a maybe here. D, add 10 to the number of days. Is 1 plus 10, 11? That one works. Is 2 plus 10, 20? No. 3 plus 10? No. The only one that's worked for us is C for that one. All right, and our final one. Input, output, press pause, and see if you can figure it out. All right, which of the following equations describes the relationship between E and F? So E, I'm putting it in, and F is when I'm getting out. So I'm going to write F here. 36 equals E times 3. So 3 times 3, 36? No. Let's see, is 36 E plus 33? 33 plus 3 is 36. So that one works. Let me try, I'm going to put a maybe here. I'll come back to it. C, F equals E plus 3. So let's see, is 36 equal 3 plus 3? No. F equals, so F is my 36, E times 12 is 3 times 12 is 36. Oh no, I'm between 2 maybes, so I'm going to check. Let's do this one again. E plus 33, so let's see. Well, I automatically see this. 6 plus 33 is not 72. So then that tells me that 6 times 12 times 12, that would work. So the answer there is D. All right. Hopefully we're understanding these. If you want to try more of these, there are these on Study Island for you to try. All right. Bye, guys.